Today, we work in a MultiCAD world with the challenge of importing and often editing data, regardless of what software created it. Here's an example of a mover assembly, where I need to import 3D supplier data from various sources and make edits where needed. First of all, we'll show you how to quickly import the 3D data. All I have to do is use the Open command, meant for Solid Edge files. This command can open several file types, including from other Siemens products like NX, besides universal formats like Parasolid, Step, and IGES. Not just that, drawings, parts, and assemblies from other CAD systems like AutoCAD, Inventor, Pro Engineer, CATIA, and SolidWorks can be opened seamlessly, all using the same command. Here's an example of a knob created in another CAD system. Solid Edge imports it as a part copy. Now it's easy to forget that this is a non-Solid Edge part, as you can work with it in exactly the same way that you would work with a native Solid Edge part. For example, specifying what materials it's made of to get the correct weight, or applying the color or finish. Nice and easy. The real challenge in most CAD systems comes when you want to edit using a history-based approach. You have to do some sort of feature recognition. But with Solid Edge with synchronous technology, all you have to do is pick a face and drag. Simple and intuitive. Notice how things change sensibly for faces that are aligned with this one. They are moving too, just as if it were an original feature in the history tree. And what if you prefer editing dimensions instead? Well, sure. Just click a face and Solid Edge will provide the dimension for you on the fly to edit. Again, note the intelligence when all the whole dimensions are changing as if they were a part of a pattern feature. If you want to add your own dimensions, you can add those in 3D. No need for hunting underlying sketches. Here we add and modify the dimensions for this thickness. Notice the control you have in keeping the top face fixed. A good need for having a history of features is when we need to reorder rounds. You can see here the previous design approach created rounds in an incorrect order, resulting in a wrong blend. Can we solve that in Solid Edge without the history? Absolutely. Just a right click and select the option to reorder. Job done. You can also make changes to the size of these rounds. By selecting one round, Solid Edge can automatically see other rounds in the model that are the same size. This way, you can save a lot of time by making one edit, not multiple edits. In some cases, though, you may want one or more independent dimensions to edit, a good example being holes. Here, we can have Solid Edge recognize the cutout as a hole so that you can go in and change the specific hole type. Here we want counterbores. They are fast and easy. You can also add intelligence to dumb models like these by recognizing holes from faces. Just ask Solid Edge to do so, and you get all holes recognized with the appropriate type. Here, Solid Edge has recognized simple holes and a counterbore hole in the center of the knob. These features are also added to the Pathfinder, so you can select them and change the diameter of the hole to one from the standards available in Solid Edge. You can also ask Solid Edge to recognize a pattern in the recognized features, and voila! You have a fully defined pattern features ready with an axis defined and the count and centerline distance, which I can modify easily. What about removing geometry? Well, that's as intuitive as deleting files in Windows Explorer. Simply fence select faces, or alternatively, choose one by one, and then press delete. Solid Edge will look after the rest. So you can see how easy it is to edit non-Solid Edge parts in Solid Edge. Very flexible. Another area of saving time is sheet metal parts. We can import these in the same way as the previous parts. Remember to simply use the Open command to read in the file. Now, we want to extract and maintain the manufacturing intent from this dumb model. Synchronous technology in Solid Edge can do just that. you can add smart dimensions directly on the model and let them control the sheet metal size and behavior. Notice as I change the distance of this hole from the bend, the adjacent hole moves as well. Thus, you can maintain the design intent without additional effort. More on design intent in Solid Edge in another video. For this, we also need to create a flat pattern. But because this part was not created in Solid Edge, how am I supposed to produce this? Go back to the supplier? No, not a problem. You can tell Solid Edge to treat this as a true sheet metal part with flanges and all standard sheet metal features, and you have an instant and accurate flat pattern. Synchronous technology in Solid Edge thus allows you to work on non-Solid Edge data as if it were Solid Edge data. Add intelligence to dumb models, recognize features and patterns, and edit using just a push, pull, or delete.